Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about another problem that we got from Singapore Maths Olympiad from 2013. In this problem, we have 2 to the power of 8 plus 2 to the power of 11 plus 2 to the power of n is a perfect square number. We are looking to find the value that we can have for n belongs to natural number so that this condition is true. Before moving forward to talk about the solution, make sure that you pause the video to think about the problem. To solve this problem, let's start with using m squared for the perfect square number that we might have. So we will have 2 to the power of 8 plus 2 to the power of 11 plus 2 to the power of n is equal to m squared. Now we are going to rearrange the equation that we have here in a case that we have 2 to the power of n on the left hand side and m squared minus 2 to the power of 8 minus 2 to the power of 11 on the right hand side. Then we can say that 2 to the power of n is equal to m squared minus 2 to the power of 8 times 1 plus 2 to the power of 3. Here we factor out 2 to the power of 8 from the two terms that we have here. With that, we can say 2 to the power of n is equal to m squared minus 2 to the power of 8 times 3 to the power of 2. Remember, 2 to the power of 3 is 8, and we have 8 plus 1 or 9, which is written as 3 to the power of 2. Now we have m squared for the first term on the right hand side, and we have 2 to the power of 8 times 3 to the power of 2 for the second term on the right hand side. We are going to use the identity that we have for a squared minus b squared is equal to a minus b times a plus b here. Obviously, we can write the equation as 2 to the power of n is equal to m minus 2 to the power of 4 times 3 times m plus 2 to the power of 4 times 3. With that, we can say 2 to the power of n on the left hand side needs to be divided into two terms, and we are looking to find the two terms that we can have for the first term and the second term. We are going to start with using 2 to the power of k for m plus 2 to the power of 4 times 3, and then 2 to the power of n minus k for m minus 2 to the power of 4 times 3. Obviously, if we multiply both sides, we will get 2 to the power of n for the left hand side. Now we are going to use a trick here. Since we don't know the value that we have for m, we are going to remove it. On the left hand side, we subtract both sides, and we are going to do the same thing for the right hand side. So we will have 2 to the power of k minus 2 to the power of n minus k is equal to 2 to the power of 4 times 3 times 2. We are going to simplify the right hand side as 2 to the power of 5 times 3. And then for the left hand side, we are going to factor out 2 to the power of n minus k. Then we will have 2 to the power of n minus k times 2 to the power of 2k minus n minus 1. From here, we need to have some reasonings. On the left hand side, we have two terms. The first term is a power of 2, and the second term is a power of 2 minus 1. For the right hand side, we have two terms also. We have 2 to the power of 5, and we have 3. Let's start with using 3 for the second term on the left hand side, and 2 to the power of 5 for the first term on the left hand side. Then we will have n minus k is equal to 5, and 2k minus n is equal to 2. If we add these two equations together, we will end up with k is equal to 7 and then n is equal to 12. Thanks for watching the video. If you would like to see more puzzles and math involved activities, please subscribe to the channel. This is the SQRT channel.